I'm Dave Wolber from USF, and my co-author is Jen. Jen, you want to introduce yourself?
Sure. I'm Jen Rosato from the College of St. Scholastica. Nice to see you all.
Yeah, great to see everyone. We got a little video, so I'm going to share my screen, and hopefully this will work out okay. Building apps with user interfaces like an Asteroid game is not really something beginners can do with a traditional language like Java. But in event-based languages, it's doable because event handlers, like when a button is clicked, are primitive to the language. With Thunkable, for instance, you just drag out a when event block to specify an interactive behavior. Here, I'm coding when the go button is clicked, get the asteroid moving. The app can be tested immediately on your phone. So that, the screen on the right is showing my phone projected to the screen. And so that's how I could do the test. You can also code more sophisticated event handlers. In this second example, I'm coding when the asteroid hits an edge, move it to the top. And the response in this case is modify the Y property of the sprite to 10, and so then that asteroid is going to reappear at the top of the screen once it hits the bottom. Anyway, there's many reasons languages like Thunkable are great for beginners. But I think these when blocks, the event handlers, as primitive constructs in the language, are key to the whole thing. And they really help give beginners superpowers and the ability to learn by creating.
So let's think about teaching event-driven programming languages and about events. A nice way to start off is to demonstrate the app for the student. So Dave was showing how to build the app. You might start just by showing them how the app works and asking them to identify the different things that are on the screen that make up the user interface and the various things that they see happening on the screen. One tool that I've used before is a planning document similar to this. It's maybe a little more structured than you might want to do for all of your apps and event-driven programs, but it helps students organize their thinking. So you could have a space where they either draw the user interface or you provide it to them. There's tables on each side, one for them to identify the various components and the properties that they might set each component to. And then another part of the table there identifies the events that happen in the program and gives some space for students to write an algorithm so that they get to start thinking about how to plan their program.